This Zoom session is being brought to you by the Fractal Eternity. All right, today we finish off chapter 1, which means that chapter 1's homework is I'm expecting you to scan it, and put it into the inbox next Tuesday. Okay, so this is about inverse functions. Okay, the inverse function, given a function f of x, its inverse is written f inverse of f. This -1, it's what I call a notation of collision because it looks like it's a reciprocal of f. It's not. Then unfortunately, the same thing means two different things. Whatever. Okay, the inverse function undoes what f does. F inverse of f of x equals f of f inverse of x. So given a number x, wherever f sends it to, f inverse sends it back again, and vice versa. So another way to put it is that y equals f inverse of f if and only if f of y equals x. So they f and f inverse undo each other. So for example, the inverse of adding 7 is subtracting 7. Here's a graph, y equals x plus 7, y equals x minus 7. The inverse of 2x, the doubling a function, is halving a function. Here's a graph of y equals 2x, here's a graph of y equals x over 2. The inverse of a cube function is the cube root function. So here, this n-shaped curve is a cube function, and this n-shaped curve is the cube root function. You'll notice that these have there's a certain symmetry between a function and its inverse. If you flip through the diagonal, you get the graph of the inverse. The reason why is simple enough. If this is a graph of y equals f of x, then y equals f inverse of x is the graph of x equals f of y. These two equations are the same except we swap x and y. So, and geometrically swapping the x and y axis is just flipping along the diagonal. So therefore, you flip a function graph of the diagonal, you get the graph of the inverse. And to find the formula, an algebraic formula for inverse, write x equals f of y and then solve for y. So for example, 1 plus the cube root of 2x to find f inverse, write f of y equals x. So 1 plus cube root of 2y equals x. Then we start clearing away everything until we get transposing until we get y. So subtract 1 from both sides, and cube root of 2y equals x minus 1. Cube both sides, 2y equals the cube of x minus 1. Halve both sides, y equals the cube x minus 1 all cubed, all divided by 2. And that is the formula for the inverse of the function, x minus 1 cubed all over 2. Now note a curious thing here. If you look at the original function x, what it does is first it doubles a number, takes a cube root, and adds 1. That's f of x. Whereas the inverse function starts with x, subtracts 1, takes a cube, and then halves. Now you'll notice times 2 divided by 2, cube root cube, 1 plus minus 1, and so on. The inverse function is the operations that created the function in the opposite order. So inverse functions are opposite operations in opposite order because you're undoing something. So you have to undo in the opposite order you did something. Now, sometimes if you flip through the diagonal, you get a graph which is not a function graph because there's two values of x, two values of y for a given value of x. Here's y equals x squared. Here's a graph of x squared equals y. Or is that y squared equals x? Oh my God. I better change that. Error. I better change 17 page, which is this? 3. Nope, 4. Nope, 5. Y squared equals x. Okay, this should be y squared equals x, so y equals plus or minus root x. Note the plus or minus. There's two functions, y equals plus root x and y equals minus root x. So it's really not a single inverse, it's a graph of two inverses. Okay, a graph function is one-to-one if its different inputs yield different outputs. Let's see. If a is not b, then f of a is not f of b. That way we can undo functions. Why is it f has a single inverse, if and only if it is one-to-one, if and only if it passes what's called the horizontal line test. That is, if every horizontal line that you pass to the function will meet the graph at one point only. Here, this is no pass because this horizontal line meets the function graph and 2 points. So it wouldn't know how to invert that particular value. All right. So some examples. Here's a graph of y equals 2.7 to the x. Is it 1 to 1? Yes. Therefore, has an inverse known as the natural logarithm. We'll see about that later. Here's a function. Is it 1 to 1? No, it is not, because this line, horizontal line, will meet it twice. This horizontal line will meet it twice. No good. So it does not have a unique inverse. Here we asked to invert 2x minus 1. So to invert it, well, f of y equals x, 2y minus 1 equals x, add 1 to both sides, 2y equals x plus 1, divided by 2. So the inverse is x plus 1, that divided by 2. And notice again, we have this whole rule of opposite operations in the opposite order. This function doubles the number, then subtracts 1. This function adds 1 and then halves the number. This one's a little more tricky because we have to do some serious algebra. Invert f equals x plus 4 over x minus 3. So f of y equals x, y plus 4 over y minus 3 equals x. So we need to solve for y. And that's tricky because here it is in 2 places. And besides, this is in the denominator. Okay, first thing we do is transpose the y minus 3. So we have no more divide signs. That's good. Y plus 4 equals x times y plus 3. Then we distribute the x over these 2 terms. So y plus 4 equals xy minus 3x. Now, we have y on both sides of the equation. We want it on one side only, and only y there. So first, let's move the xy to the left by subtracting it from both sides. I'll move the 4 to the right by subtracting 4 from both sides. When you do that, you get y minus xy equals minus 3x minus 4. Removing the factor of y, you get y times 1 minus x equals minus 3x minus 4. Divided by 1 minus x, you get y equals negative 3x minus 4 over 1 minus x. And that's the inverse function. Inverse to this function is this, minus 3x minus 4 over 1 minus x. Here, to invert the 5th root of x minus 7, we start off with 5th root of y minus 7 is x. Take 5th powers, y minus 7 equals x to the 5th. Add 7, y equals x to the 5th plus 7. And that is the function inverse to this. And similarly, we have another one of these, which are called, incidentally, are called linear fractionals. So it's a ratio of linear functions. So f equals x plus 1 over x minus 3. To invert it, we'll start with f of y equals x. So y plus 1 over y minus 3 equals x. We'll solve first by transposing the y minus 3. Y plus 1 equals x times y minus 3. Distribute the x. Y plus 1 equals xy minus 3x. And so we'll want to get the y terms on one side and the constant terms on the other. So we'll subtract xy from both sides and subtract 1 from both sides. We'll get y minus xy equals minus 3x minus 1. Now we have these two y's. We condense into a single y by factoring it out. Y times 1 minus x equals minus 3x minus 1. After a division, y equals minus x minus 1 over 1 minus x. And that is the inverse function. Here's a conversion factor from F degrees Fahrenheit to C degrees Celsius. The Celsius measure is 5/9 of the Fahrenheit minus 32. All right. The question is to find, if given various values of F, what's C, and find F in terms of C. Okay, finding C given F is just a matter of substituting in 59 here or negative 4 here. And this comes out to 15 degrees. So 59 Fahrenheit is 15 Celsius. Negative 4 degrees Fahrenheit works out to be negative 20 Celsius. Now, to find F in terms of C, we start with this. C is 5/9 of F minus 32. Multiply by the reciprocal of 5/9, that's 9/5. And it cancels on the right and left, you get 9/5 C, which equals F minus 32. And add 32 to both sides, you get 9/5 C plus 32 equals F. So given a Celsius, this is its Fahrenheit measure. Here's a function, a graph of a function. What's the graph of its inverse? Well, we flip through this diagonal and get this graph here, and that's the graph of the inverse. Okay, that's it for this section. Well, like I say, we finished off with chapter 1. Chapter 2 starts off with trigonometry, and we'll start off with defining angles and how to measure them. Acute angles all the way around the protractor. 1 degree is one rotation is 360 degrees. Conversion to from degrees, minutes, seconds to decimal degrees, and vice versa. And there's something called radian measure, which we'll be discussing, a kind of natural measure. And we'll talk about areas of sectors, lengths of arc lengths, and so on. And that will be that for that. Okay, I think we're done for now.